To get an understanding of compartmentation at work, let's take a look at this example. So this was a group of factories separated by a firewall. Obviously there's been a fire on one side and the firewall has been really effective to stop fire spreading from one compartment to the next. This way the people can get out safely. The brigade got in and extinguished it before it could jump over the firewall. And from an insurance point of view, you only have to rebuild half of this building. The other effects of this is that the workers who work in the other side that hasn't burnt down, they can come back to work the next week. So there are some longer term effects that come out of these fire events just beyond the initial damage. A good way to think about passive fire is like a warship. If your warship gets shot in the side with a torpedo, you can close the bulkhead doors to stop water spreading through the ship. And that way the ship stays afloat. It's a very similar concept we're doing with fire compartments in buildings. If the building is full of holes, the fire's going to spread. In the same way, if the ship's full of holes, it's going to sink. So we're going to try and minimize or seal up all the gaps and holes in our fire compartments in the building. From a design level, if you are looking at designing a building for passive fire protection, the NCC will tell you where your fire compartments need to be and how big they can get, depending on the type and class of building. And that's when the architects and building practitioners will design in your fire-rated ceilings, floors and walls. If there's structural steel holding up the building, you might need to apply for passive fire protection to provide a structural rating to the steel so that it doesn't collapse during a fire. If you've got ducts that pass through your building, you're going to need to look at fireproofing the ducts or put in fire dampers to prevent fire spread. And then joints as well, between all of these elements. Between the walls and floors and even the external facade of the building, there will be gaps that need to be fire sealed to prevent spread of fire. And from a design point of view, that's a relatively simple thing to do. The challenges typically come when you get service penetrations, and that's really what this web series is going to focus on. So if you think about it, mechanical, electrical, plumbing, there are so many different types of building services. The ductwork, the air handling, and then the refrigerant pipes where you might get quite combustible laggings on metal pipes that would burn and contribute to the fire as they penetrate through an element. You've got electrical, power, data, cables, cable trays, bundles. You're getting all these different types of modern cables now with different cores, different conductors, fiber optics, lots of plastics in all different sorts of configurations. So it's really difficult to try and come up with a one-size-fits-all approach. And then with plumbing, plastic pipes are obviously going to melt during a fire, leaving a hole. Your metal pipes typically don't melt, at least not before a certain temperature is reached, but they will transfer a lot of heat through the fire barrier into the other compartment, which can then ignite other materials. And now in modern construction, we have composite pipes, which have plastic and metal components, so you get the worst of both worlds. So our challenge in passive fire protection is to come up with bespoke solutions to seal each and every one of these services as they penetrate through the various fire compartments. And that's really the nuts and bolts of passive fire protection. So join me in this series, watch the next 3 episodes, and we'll have a look at some of the regulatory requirements as to what you need to do to come up with a tested system for these things. And we'll learn about the fire testing, the FRLs, the relevant codes and standards that you need to apply to, so then you can make your product selection. I'll see you in the next episode. Thank you.